Good afternoon, everyone, and welcome to the 9th instalment of our Practitioner Education Series. Today we're going to hear from Gotch Gorgeski, Manager of Proactive Building Inspections, and Matthew Fithall, who's a Technical Advisor within the Technical and Regulation Unit, to discuss Proactive Inspections Program and the building inspection findings as they relate to timber framing. My name is Stuart Draffin. I'm the Director of Audits and Inspections at the VBA, and I welcome you to today's session. I'd also like to acknowledge that we begin by acknowledging the land which we traditional custodians of the land in which we meet today, which for me is the Wurundjeri tribe of the Kulin Nation. And I pay my respects to the elders past and present, and I extend that respect to Aboriginal Torres Strait Islander peoples who may be here today. The VBA launched its Proactive Inspections Program, or as we know it, PIP, in 2015, and is involved with checking of building and plumbing works under construction with the purpose of reducing non-compliant building and plumbing work in Victoria. During today's session, we'll be looking at the PIP building inspection findings as they relate to timber framing. This will include a review of a number of photographic examples of what we've found and descriptions as to why they are non-compliant. Following that, there'll be discussions on what the regulations require to ensure compliance. Later in the session, there'll be an opportunity for some questions that you'd like to draw your attention to. Could I particularly draw your attention to the Q&A icon at the bottom of the screen? We'd like to encourage you to type your questions there throughout the session so that Gotche and Matthew can address as many of your questions with the time remaining. Can I just emphasise though, please put your questions in the Q&A icon. We'll be referencing that. The chat room, if you want to chat amongst your colleagues, that's fine, but questions need to go in the Q&A icon. If I could also remind you that today's session is being recorded and we'll be making it available on our YouTube channel shortly after the session with our previous webinars. So I'll hand over to Gotche at this stage and come back to you near the end when we'll start going through the question and answer segment. Gotcha.
Thanks, Stuart. Good afternoon, and thank you all for attending today's session. Today, I will give you an insight into the Proactive Building Inspections Program and identify issues and concerns identified by the team. Firstly, some background on the Proactive Inspections Program. The Victorian Building Authority Proactive Inspections Program involves teams of building and plumbing inspectors who are VBA authorised officers inspecting building and plumbing works under construction throughout Victoria with the sole purpose of reducing non-compliant construction work. The program was designed to engage with all practitioners and enforce compliance with the Building Act, building regulations and plumbing regulations prior to occupation taking place. By inspecting work under construction, the VBA can address significant failures early, resulting in better outcomes for all involved. Rectification is often easier, where the cost of rectification is covered by the practitioners and not the homeowner. And it avoids impacting the health, safety, and amenity of future residents if the non-compliance had remained undetected. Our goal is to undertake inspections of at least 10% of all building permits issued per year across the entire state. When selecting the sites for inspections, we rely on building permit data and consider a range of risk factors. We focus on certain types of construction to manage risk and to ensure intervention at the earliest stage possible. The VBA uses a risk scale system to determine the level of scrutiny it places over a potential issue. The scale considers the potential adverse effects of the safety of the building, occupants and people nearby, and on the amenity of the building. When an inspection is completed, a risk rating is provided, depending on the level and amount of non-compliance issued identified on site. When our inspectors identify compliance risks, they write to the practitioners notifying them that there is an issue to be addressed. The practitioners are then required to submit evidence of the rectification works or document-based evidence where required. In some circumstances, the VBA will issue a direction to fix to resolve the most critical issues. Examples of when direction to fixes would be issued, where the issuing of an occupancy permit is imminent and serious structural non-compliance has been detected, where the next stage of work is commencing that will fully enclose the faulty building work. And another example is where the builder and relevant building surveyor consistently fail to provide adequate responses within required timeframes in relation to the number of PIP inspections. The different risk ratings of letters that can be issued range from low risk, pass to high risk. Low risk, normally non-compliance is not identified at the inspection, or any non-compliance is consistent with the work in progress. Low risk, low impact non-compliance, it is unlikely that the non-compliance, if left untreated, would cause an adverse effect on the safety or amenity of the occupants. The medium risk issues, if left undetected, it is possible that the non-compliance would cause an adverse effect on the safety and amenity of the public, and also financial loss as well. And high risk issues, it is almost certain that the non-compliance, if left untreated, would cause an adverse effect on the safety or amenity of the occupants. Structural integrity will be significantly compromised, or total loss of the project value. Examples of a few high risk issues are deep or dangerous site excavations along the boundary, fire risk issues relating to penetrations and party wall installations identified, issues identified in slab reinforcement with the likelihood of the builder pouring concrete the next day, and swimming pool construction in the backyard that has not been fenced off, just to name a few. Recent findings. A tad over 4,000 inspections were conducted in Q4, comprising of 2,252 building and 1,796 plumbing inspections. They were conducted across 50 municipalities in Victoria, covering 722 builders and 174 building surveyors across the state. 28% of the overall inspections showed compliance risks. A total of 1,139 notifications have been sent out. The most common non-compliance issues that were found on site were to do with timber framing, unreinforced brickwork and accessories, footing, slabs constructions and subfloor, and damp and waterproofing. Framing was considered the highest, so for the purpose of this presentation, we're going to focus on the timber framing defects. Other defect findings will be presented most likely at a later stage. So in today's session, we'll be highlighting the most common issues the inspectors identify on site that relate to timber framing. It will provide examples and explanations of defective building work we identify and how they have been rectified. In most cases, when the team attends building sites, the mandatory frame inspections have not been approved and the roof is already loaded. The majority of these items in the following slides have been identified after receiving confirmation from the relevant building surveyor that the frame inspections have already been conducted and approved. It is possible that if it was left untreated or were not detected throughout the proactive inspection program, would have caused an adverse effect on the health and safety of the occupants and future financial loss to the owners. Our aim today is to highlight various issues the team identify on a weekly basis. Various before and after shots have been provided showing compliant and non-compliant construction. We'll kick off with an easy one, but a very common one. Bottom plates overhanging the concrete slab. The photographs below highlighted red show the bottom plate overhanging the slab. This is not compliant. Under the Australian standards, there are no prescribed allowances for that timber bottom plate to overhang. It is defective building work. The guides to standards and tolerances currently under review allows a 90mm stud to overhang only a maximum of 10mm, but this is a guide. Areas that exceed the allowable tolerance require a review from the relevant registered civil engineer to provide evidence that compliance with the NCC 2019 Volume 2, Part 2.1 is satisfied. The rectification of the overhang highlighted green is still in progress. As you can see in the photo, the builder has to provide starter bars drilled into the slab, boxing yet to be done, then to bulk fill with concrete to achieve compliance. This was designed by the civil engineer and approved by the relevant building surveyor. Attached are some more examples regarding bottom plate overhang in the slab. The top left photo shows the bottom plate installed correctly. On the same job, a section of the bottom plate, when measured, was overhanging the slab by 30 mil. As there are no prescribed allowances for the timber bottom plate to overhang, it is a non-compliant building work. A common rectification detail on site normally involves a steel angle diner bolted to the slab. As you can see in the photo below, highlighted in green, this builder has installed a treated pine H4 timber diner bolted to the slab at 450 centres. This rectification was designed by a registered civil engineer that complied with Part 2.1 of Volume 2. Also, when the bottom plates overhang the slab, please ensure the minimum cavity widths are not compromised when the brickwork commences. These photographs below show excessive notching and cutting to bottom plates and studs. This is deemed defective. The Australian standards allows for a maximum hole of 25 mil on the face of the bottom plate. The structural integrity of the framework has been compromised in the photographs. Part 6.2.1.4 of the Australian standards must be followed. To add, whether notching exceeds this in a braced wall, consideration must be given to Part 8.3.6, noting that sheet bracing walls require a continuous bottom plate. Studs were also not evenly spaced as required by the Australian standards to suit loads, lining and cladding fixings. When they are cut and do not run the full height, this is no longer achieved and is deemed defective. Braced walls. The first photo shows an existing timber braced wall, highlighted in red, has been cut so a post can be installed. This is deemed non-compliant. The buildings are designed to resist imposing forces. Alterations and additions should factor in existing braced walls to ensure that they are not compromised as part of the new work. They should be reinstated or another suitable wall to be nominated and be braced. In the second pic highlighted green, the rectification was to install a new steel bracing where the existing timber brace was cut. Compliance was restored. In the third picture, the metal bracing does not span the full length of the wall. This is defective. Metal bracing is required to span from the top plate down to the bottom plate. Where the bracing is cut, as identified in the photo, to allow for plumbing work, the wall is no longer working towards providing the initial assumed bracing capacity. Once the plumbing work has been completed, the bracing should be reinstated as originally designed and constructed. The team inspect a lot of braced walls. Bracing is normally not installed on a 30 to 60 degree angle, and as you can see in the last photo, the braced wall was measured less than 1.8 in width. For compliance to be achieved, the braced wall width should be between 1.8 minimum and 2.7 max. These minimum and maximum requirements are straight out of the Australian standards. In this next slide, it's more of a design oversight. When considering the location of braced walls, it is important to factor in the proposed service fittings that are going to be installed within that wall. Consideration was not taken into account for the services to be installed. The bracing has to be cut to complete the mechanical services and will compromise the initial bracing capacity. The bracing has already been cut when the taller fittings were being installed. This is defective building work. The wall is no longer working towards providing the initial assumed bracing capacity. The bracing should be reinstated. If it cannot be reinstated, another wall may be required to be braced or alternative brace sheeting provided to achieve compliance. This obviously must be discussed with the relevant building surveyor or engineer. Excessive notching of braced walls is pretty common. Ensure that the manufacturer's installation guides are being followed so that the wall can still provide the required bracing capacity. Depending on the sheet bracing being used, most commonly areas within 300 mil of the corners should be avoided. Small diameter service pipe penetrations of approximately 30 mil should only be drilled a maximum of 4 per sheet, and large service pipe penetrations a maximum of 150 mil are limited to 1 per sheet. Also, unless otherwise specified, the sheet bracing must span a minimum of 900 mil wide. The top right photo, to achieve compliance, the bracing had to be replaced due to the excessive cuts. Australian Standard 1684 requires that the sheeting be continuous from the top plate to the bottom plate, with any horizontal sheet joints made over noggings with the same fixings as the top and bottom plate. Part 8.3.6 of the Australian Standards outlines the required installation for different bracing units. The installation of the floor joists. In these photographs, a few floor joists have been installed incorrectly. A simple installation error by turning it around the other way may have caused this defect. Not installing them the right way up is a defect. When installing floor joists, it is important to ensure that the manufacturer's installation guides are followed and that they are installed the correct way up. Rule of thumb, unless clearly marked up otherwise, posi struts are always manufactured so the posi web starts at the top chord at each support point. Please refer to the bottom 2 diagrams. The green highlighted equals compliant. Damage to the floor joist. In the first photo, the internal steel web to the floor joist has been damaged and removed, deeming it non-compliant. It was removed to make it easier to install some cleats bolts to the blue beam to beam connection. Some might say it's only a web, she'll be right, but altering or removing webs to posis is a defect and affects the integrity of the product. If the webs have been removed or damaged, the manufacturer must be contacted for a rectification detail. In the second photo, highlighted green, the rectification required was to install new steel webs with timber screws to the posis as per the manufacturer's request. This made it compliant again. If you have to remove it, let the supervisor builder know and don't just turn a blind eye and hope no one notices. The last picture shows the bottom flange of the joist damage. This joist should not have been installed in the first place. Builders should take note and ensure materials are good and suitable for their purpose for which they are used, unless otherwise stated in the domestic building contract. As you will see in the next 2 slides, the plumbers have had a field day. These items are identified on a daily basis by the team. By highlighting these issues, we hope to make various trades supervisors and builders aware that this practice and advice is defective and not acceptable. The structural integrity of the product has been affected. We encourage inspectors, supervisors and builders to keep a lookout for this item, and if noticed, raise it and work with the engineer and the relevant building surveyor to rectify it. If left undetected, it could lead to serious structural collapse. It's critical that supervisors, builders are aware of this practice occurring, as 8 out of 10 times the frame inspection has already been approved prior to any services being installed. The last photograph highlighted green, the builder had to provide a new vertical support timber and new horizontal members to the top flange, as designed by the posi manufacturer. Once works were completed, it was deemed compliant. On this slide, some more examples of holes and cuts in the floor joist. These jobs were at lock-up stage when the team identified these items. A high-risk letter was issued to the builder and relevant building surveyor. The builder had to rectify the issue and fix an additional 90 by 35 structural member, minimum 2.4 metres long, to one side of the joist, highlighted in green, as per the engineer's detail. Keep in mind that these are engineered products and any alterations or rectifications of the products must be designed by the manufacturer and provided to the building surveyor. The photo on the far right identifies cuts to the E-joists that are not neat and within 5 mil of the flanges. This is deemed defective. With so many different products in the market, it may be confusing to keep up with the requirements. When using E-joists, the cuts must be neat and not within 5 mil of the flanges, as per the manufacturer's installation guidelines. The spacings of the holes are also important depending on the width and diameter of the holes. Please ensure that the correct manufacturer's installation manuals are followed for the product used on site. The most common defect the team identifies on site are to do with floor joists and the lack of end blocking and bracing. Not providing blocking or bracing is a defect. The blocking or bracing at the ends of the floor joists are critical as it provides lateral support to resist raking effects imposed on the structure. Depending on the product and method of bracing used, it can be between 1.2 to 2.4 max. In the first photograph highlighted red, the blocking has not been provided at 1800 centres. This is non-compliant. As you can see in the following two photos, blocking has been provided at 1.8 centres in line with the manufacturer's installation guide. This is now compliant. Continuous blocking also needs to be installed below the second story braced wall in accordance with the manufacturer's installation guide. In the attached photo far right, they have provided the continuous blocking under the sheet braced wall above, but are yet to provide the tie downs, deeming it non-compliant. Tie downs at each end of the panel are required to make it compliant. In the first picture, no end bracing was provided to the posi joist. This is defective. Timber diagonal bracing, speed bracing, or plywood bracing can be adopted. Depending on the method selected, the spacing of the bracing will change. In the middle photo, the builder chose to use timber diagonal bracing. When timber diagonal bracing is used, it's required to be provided at 1200 centres. The builder did provide timber diagonal bracing at the required locations, however, missed additional requirements to provide triple L grips to the ends of the posis. Triple grips or universal grips are required at these locations as detailed in the manufacturer's installation manuals to connect the brace walls, to connect the brace floor joist down to the top plate. If not provided, the connection is non-compliant. The last example, no end bracing has been provided to the ends of the internal posis. This is once again defective building work, and depending on the bracing method that will be selected, it will most likely require triple L grips. The other less common bracing to the ends of the floor joists we see on site, but not as much these days, are speed bracing, plywood sheet bracing to the posis. They are required at 2.4 centres. Always install it in accordance with the manufacturer's installation guide. The manufacturer's guidelines are all easily accessible on the web and are also provided at the time of delivery of the product. I guess for the building inspectors in the group, make sure you have the latest installation guides handy. Strongbacks. As you can see, once again, various structural members have been removed from trades when running their services. On this occasion, they have cut through the strongbacks. This is non-compliant. Why are strongbacks important? Well, they are required bracing elements as part of the design as a whole. They also provide load sharing and increase the floor's stiffness that in turn reduces squeaky floors as well. The performance of the floors depends highly on the insulation of the strongbacks. By cutting and removing the strongbacks, you affect the structural integrity of the overall design. A fun fact, for optical performance, ideally the strongbacks should be installed hard up against the top chords. Once cut, rectification involves a pair of 90 by 35 battens fixed to the underside of the top chords each side of the strong backs, spanning across minimum 3 posses to make it compliant. This design is directly out of the installations manual. On the top right-hand side photo, highlighted in green, an engineer's design was received that allowed for one metal batten to be installed spanning 4 posses located directly adjacent to the existing cut. Once installed, the works were deemed compliant. Fixing of trusses to internal walls. The photo on the left shows that the slotted L brackets have not been installed at 1800 centres. This is deemed non-compliant. The Australian Standards 1684.2 requires internal non-load bearing walls to be provided with slotted brackets at 1.8 centres to allow for movement when the truss is loaded. For an internal non-load bearing braced wall, the truss must be fixed to the top plate of the wall that restrains the truss from horizontal forces, but allows for movement upon loading of the truss, as specified in Australian Standards 4440. The photo on the right is deemed non-compliant. Adequate fixings are to be provided to internal walls, especially for braced walls. If in doubt, please refer to Table 8.22 in the Australian Standards with various methods that can be adopted. Half trusses. In this slide, the ends of the half trusses have not been provided with bracing, highlighted in red. When bracing is not provided, it's deemed non-compliant building work. Typical fixings seen on site may include steel bracing and timber diagonal blocking. On the bottom left-hand side photo, highlighted in green, diagonal timber bracing has been provided. This is compliant building work. On the bottom right, speed bracing has been installed, once again highlighted in green. We have also highlighted the same photo in red. The steel brace is not bent and nailed to the side of the top cord. And to make matters worse, a timber block to the top cords fixed to the trusses have not been provided, therefore deemed defective. Bracing is critical to ensure that imposed forces are transferred back to the supporting structure. The Australian Standards 4440 Part 4.3.A nominates the required fixing of the bracing to the end of the cut or half trusses. Always install it in accordance with the manufacturer's installation guide. They provide clear and very detailed methods. As inspectors, ensure that builders follow the manufacturer's installation manuals on site. Other structural issues. In these photographs, the concentrated loads were not transferred down from the first floor down to the ground floor. This is defective. They went to all that effort to cut the blocks to fit in between the ground and first floor, but forgot to provide the double studs down to the slab. This is non-compliant. This is a high-risk issue if left undetected. Why are these critical? It is important to the structural stability of the construction that all load-bearing concentrated load points are transferred down through the structure and onto the footings. In the middle example, blocking has not been provided between the ground floor and first floor. The ring beam is not sufficient on its own, deeming it non-compliant. In the last example, highlighted green, blocking was provided to transfer the loads from the first floor to the ground floor. As you can see, double studs are also provided. This is compliant building work. To round up today's session, the remaining common issues identified from the team in quarter 4 relating to timber framing were double studs, jam studs have not been provided to the ends of the lintels in photo 1, deeming it non-compliant. In photo 2, the wailing plate has been cut from the surfaces to be installed. And the last 2 pics, the tie downs to jam studs and the top plate lintel connections are often missed and deemed non-compliant. All 3 examples above are defective. I know some of you may find these items in this presentation alarming. This is what the team faces on a weekly basis. Thank you all for your time, and I hope you all got something out of these issues. For those of you who are interested in the Proactive Inspections Program and want more information regarding the quarterly report, please jump onto our website. Further case studies are also available within the report. Details will be on the slides. Thank you.
Thanks, Gotcha. It's been very interesting watching the chat space while you've been presenting. There's been a lot of really good discussion occurring in the chat space amongst the practitioners, and there's also been some great questions put forward. I think one of the key takeaways from the presentation is the visual images assist people in understanding the nature of the issues that inspectors see and where they are either failing or compromising expectations, and then the rectification measures to pursue. What we might do now is turn to some questions that have been posted and actually see if we can share them out. One question would relate to a purely administrative part of this is this presentation available later on? The simple answer is yes. We're going to put this on our website and it'll be available in a YouTube format at a later stage. So that will be it. Matthew, do you want to, there's a question there about the inspections being responsibility of the relevant building surveyor. And Matthew, you're going to respond to that, I believe.
Yeah, I think that the proactive inspections and you've got relevant building surveyor, they're sort of two different things. So the relevant building surveyor still has a function under the Act, and then the proactive inspection is a separate process. So the proactive inspection doesn't take away from the function of the relevant building surveyor. It's probably the easy way to answer that question.
Yep. The chat has also talked about the interaction between plumbing work and framing work and the impact on that. I'm just wondering whether one of the panelists would like to comment on the impact of plumbing work and how that's best managed. No?
Is that a question to me, Stuart? Or sorry,
I'm leaving it open to anyone in the panel who may want to respond to it.
I guess we all play a responsibility in this. I guess when the inspectors inspect a site for a mandatory frame inspection, most of the surfaces aren't actually put in at the moment. It's normally done at a later stage where the supervisors or builders are on site and the plumbers will just do the work. So we can't put the blame on relevant building surveyors or inspectors because by that stage the frame has already been approved.
Yeah, and I suppose what it does highlight though is the need for vigilance around whilst the frame may have been completed and may have even been signed off, there's clearly work that's going to be done post that frame inspection, and the need for builders and building surveyors and inspectors to maintain vigilance around what work might then compromise the frame at a later stage. Clearly, the photographs that have been supplied throughout Gotcha's presentation have shown a lot of work that has compromised what might have been an otherwise compliant frame. So it's well worth being conscious of that potential impact. The question around the quality of this material being available to apprentices and the like, yep, absolutely agree. We're happy to make that available. Matthew, you're going to answer a question relating to bottom plates are cut and can they be fixed off to slab on either side of a cut?
Obviously, we can't, from this perspective, be site specific about where it's allowed or not, but obviously there's a requirement with the plate and the studs not to be doing that sort of thing. So where the solution will deviate from the 1684 part 2, normally it'll have to be sort of the engineer will often have to approve. I think he was saying at the very start of the presentation, you've got the engineering sign off when something like that actually happens. If it's a deviation from 1684, unless it's designed under 1720 part 1, it usually it's in relation to an engineer that needs to sign off. So if you're going to do something like cut the bottom plate to such a degree as the examples that were shown, and have another solution for that, at the end of the day, it's about engineering. It will be about whether the engineer is signed off, and it'll come back to the relevant building surveyor is happy with that solution with the sign off from the engineer as well. If it's a deviation, I think that's probably the general way I can answer the question without getting too site specific.
Sorry about that. There's a question relating to any plans to make carpenters a registered trade. There is actually work progressing in that space as we talk, and there's some regulatory impact statements being done in that space. So yeah, longer term, there is intention to have some registration requirements around carpenters. There's a question relating to, sorry folks, I'm just trying to pick some samples out to try and cover them. How many inspections without the plumbing stack rough-in actually were completed and had inspection carried out by the RBS? Is anyone able to respond to that question? No, we'll take that one.
I haven't got the specific details for that answer. Sure.
Yep. Okay, thanks for that.
There's got one question here. Once a PIP occurs, if after the RBS has approved the frame, who becomes responsible for the final approval? The RBS is the one that'll be responsible for the final approval. Depending on the items identified, they're going to need to be rectified by the relevant parties, and then the RBS has to give the final tick of approval for the frame.
Yep, okay. There's a question here relating to why don't we have an additional mandatory inspection at lock-up stage in terms of eliminating uncompliant issues. What are people's thoughts around that? Too sensitive a topic?
Guess, yeah, it's probably a too sensitive topic, but I know the first building surveyor like I ever worked with, depending on the builder and if it was an owner builder, he always used to call for a pre-plaster lock-up inspection just to satisfy himself, because as a relevant building surveyor, you're taking the full responsibility of the job, so you've got to be certain that work on site is compliant. So that was part of his recommendations for people like to use his services. So I guess, although it's not mandatory at the moment, building surveyors can ask for that as part of their services.
Yeah.
Yeah, I just think I'll probably add to it. I was just going to say, so the Act is what the minimum requirements are. So you have your mandatory inspections, and then you have the like where the engineer is required to do the inspections. But just because it's the minimum requirement under the Act doesn't mean that the relevant building surveyor can't cause an inspection where necessary if they really need to. I think if they're really worried about something happening in between those two mandatory stages. So they're not limited to the function under the Act, I think, with respect to mandatory inspections.
Yep. There's a question in the room that's not a technical one in terms of framing and the like, but it's a more general question about inspections and OHS compliance, particularly the vaccination requirements. So it's a left field question relating to general activity. At this stage, the advice we have from government is, as per construction activity workers, VBA officers and inspectors also are classified as part of the construction industry, and the mandatory vaccination requirement is also part of that exercise. So the VBA is currently going through a process of recording vaccination status and the like of its officers to satisfy that requirement also. and that then requires satisfaction for when they enter a site. So yeah, we're all trying to weave our way through that little minefield at the moment, all at the end of the day wanting to maintain industry compliance. Gotcha or Matthew, can you see, are there other questions that you might like to respond to for me?
I think there was one there about the posses, the posse struts. I think like it was picked up as pretty common that there's an issue where they're putting them in the wrong way around. I think the first part of the question, I think it was more about when installing the posses, I think it said, just checking that it's correct in saying that the timber posse braces run opposite to the metal. I think we've got to be a bit careful. I think in the first instance, you really need to pay attention to like the main manufacturer's inspections. The wording talks about it's being joined from the top cord to the support. The web should be to the top cord of the support, and unless otherwise stated, usually it may say this way up, and that's where you would have it the other way up in that instance. But I think the easiest or probably the best answer I can get to that, give to that question would be just to read the manufacturer's specifications really carefully. They actually have some really good diagrams on those manufacturer specifications of how they should be installed as well. So it's both visual and written. So if you're having any issues with interpreting that, I think it'd be recommended just to have a look closely at the details. There's two main, I won't say the names of them, but there's two main companies that do provide really good manufacturer specifications for posse struts. And they've got really good examples in both those manufacturer specifications showing how they should be installed. So I'd say just check them out. It's probably the best way to understand how they should be installed.
Thanks, Matthew. There's actually been a suggestion in the chat space about doing another seminar of this nature along the lines of what builders need to know about plumbing and what plumbers need to know about framing. That's actually quite a good suggestion. We are running a series of webinars in the plumbing space, but I think the opportunity to actually bring the two together and showing some of these examples of plumbing impact on frames and the like could well service the industry well, because at the end of the day, it's not just black and white of plumbing and building and the like. They all work together. So where they're impacting on each other, it's a good chance to share that insight and knowledge. And as you would have seen with the images provided, they actually are quite telling and quite instructive as to some of the problems that are observed by the inspectors. Matthew or Gotcha, any other questions in there you'd like to grab a hold of?
There was one question about why isn't the frame inspection done after the plumbing services have been installed? You run the risk of potential safety issues or structural issues not being detected early. So the frame should really be inspected prior to the roof being loaded and be exposed so the inspector can do a thorough inspection while still exposed.
Okay. Matthew, you want to grab another one, mate?
I think I'm just scrolling through madly because there's a number of questions there. There's about 83 questions for those who may or may not be able to see them. So I'm just scrolling through madly. So I'm trying to get to them as best as I can. I'm just going through. There's one about get the engineer to sign off on the frame stage rather than the RBS. At the end of the day, you can have the engineer sign off on a frame stage, but the RBS is the one who's issuing the building permit. They're the ones that are responsible for issuing the occupancy permit and the building permit. So it's a legislative function of the relevant building surveyor to have the final sign off on those for the purpose of those two permits. So the engineers might issue a certificate of compliance, and so from that perspective, they're certifying that the work or the design of the work complies. That's their part, but it's a legislative function of a relevant building surveyor to actually have the final sign off. So it's a function under the legislation. So yeah, so they both, in a way, they both kind of sign off on it, but at the end of the day, the relevant building surveyor has the last say on their compliance.
Thank you for that. There's a question here, I'll just read out. Sometimes a builder will call for a partial inspection of the frame, usually so they can install a roof or begin the brickwork. Would the VBA allow this, and should the entire frame be completed before inspection?
It all comes down to the relevant building surveyor.
Yep.
Yeah.
Okay. I'm just scrolling through some questions. Sorry, bear with us, folks. There's actually a lot of questions. We're just trying to get a fair representation of the questions put to us. There's a question here: is the VBA, or can it, share all of these findings with other industry peak bodies representing those that are responsible for defects in the first instance, i.e. HIA, MBA, etc. We certainly are working hard to maintain and build on a strong relationship with representative bodies, and wherever possible, we do like to feed back our findings and the like. The engagement with those organisations tends to be at a more strategic level about the broader aspects of the industry, but certainly if there's opportunities for space for engagement with those organisations and the insights we're seeing, we're more than happy to do that. We see these training opportunities and webinars as the opportunity to share information in the industry. What we might do now, if it's okay, is we might wrap up today's session, but what I would like to really do is encourage, first of all, thank everyone for attending. Those who won't be aware, but from my screen, it looks like we've had around about 750 people attend today's webinar, which it's really encouraging. It shows the industry is very engaged in the opportunity to do further training and development. This is a series of webinars, and we're always looking to improve both their delivery and also their relevance to industry. To assist us in doing that, we'd like to encourage participants to complete the post-event survey. That'll give us feedback on both the delivery and methodology around the webinar and its communication to industry, but then also issues and topics of interest to you, so we can maintain the relevance of the service. I would also make reference, if you weren't available, on the website, you'll find that we've had previous webinars are available on our website for recent on-site inspections and enforcement activities. So you can always return to those. And in fact, we had quite a strong response from people who are interested in that space. So we might wind it up there. Thank you very much for your attendance. Hope everyone's staying safe. And we're also hopeful that the industry will be able to get back out on site as soon as possible and start with your projects again, rather than being in further lockdown. VBA has been actively working with the health department to try and improve the knowledge in that space, and our inspectors are continuing to be out in the field to try and help the industry get back open. Thank you for your time and your interest. Have a great day, and I hope you enjoy the long weekend. We're starting tomorrow. Thank you, everyone.